Welcome. My name is Erik Gross, and you are here for a free Python class. So that's me. I'm a senior level software developer. I've been coding computers since I was before I was even a teenager. That's a long time ago. I am a veteran of the Navy, as I said. I was a reactor operator in the Navy, which meant I got to learn a lot of really, really cool things, including, applicable to what we're doing today. They taught me how computers work all the way from like the bare metal up. So the actual physical way you construct the tiny, tiny elements that make up a computer, into how you would make memory devices and how you would make a central processing unit and how the whole machine would work, and then layers and layers on top of that. So, hey, Nathan. And I'm very thankful for that, because it's that solid foundation in the utter rock bottom fundamentals of how a computer works. It's made it so that each time major shifts in technology happen, and they happen all the time, right? Each time there's been major shifts in technology, I've been able to pretty quickly pick up what's going on, not because I'm necessarily smart, but just because that foundation is really solid. And the Navy did that for me, which is pretty cool. I am the co-founder of the Tech Academy. More about that later. A couple things about class rules. We have an assistant in the chat, Regina. She's here to monitor the chat, answer questions, say hi to everybody. Please be nice. If you're not nice, she'll remove you. Enough said on that. I want to stress that while these are introductory coding classes, and we work really hard to make them easy to get through, you may run into challenges. And part of the training process is working through the challenges. So use chat as needed. Regina's led hundreds of these free coding classes and can usually help with things. I also answer questions as we go back and forth. One thing I can tell you right off the bat is when we get to the point of tonight's class where we're writing code, please ensure that you type the code exactly as written. And the reason for this, some of you may already know this, you've been messing around with coding, a misspelled word or a missing symbol, or even something that's capitalized when it shouldn't be, can result in errors in your code. So just try to type exactly what I'm doing. I'll try to go slow. And of course, sometimes I mistype because that's human. Another point, if you're attending on a mobile device, you can listen. It's ideal to do the event on a laptop or a desktop so you can actually write the code. But if you don't have access to that and you're on a mobile phone, it's fine. Still watch the event. You'll learn a lot, even if you can't write the code, although it's best to be able to write it. One big thing, please make sure you're in a distraction-free environment so you can focus on the class, and that way, hopefully I won't lose you. Finally, if you fall behind, like you're trying to keep up with the code I'm writing, if you fall behind, don't freak out. Just stop and just listen and learn. You're going to get the full code at the end of the class anyway, and I don't want you to be so distracted about like, oh, what was that thing, and I messed up, or I'm behind everything, that you don't catch the actual learning part of it, which is the most important thing. We will put this is recorded, and we'll put the recording on YouTube either later today or tomorrow. And as I said, you'll get a full copy of all the code that we're doing at the end, and you'll be able to play the game we're going to build, which is pretty cool. And finally, we'll provide a bunch of links at the end of the class to future events, the free videos, including the recording of this class, and lots of other resources. So chat works. We've had a few other people pop in since we started. So do me a favor, if you're listening and you've never attended one of our free classes, please drop into chat and let me know where you're joining us from. There's a good number of names I recognize and some ones that I don't necessarily, but I don't remember all of them. So if you've never been to one of these classes, let me know where you are. All right. Well, thank you all for tuning in. Let's go ahead and move on. So basic agenda. Oh, Reem is joining us from Portland. Yay, Portland. I lived there for 29 years. Love that place. All right, so we'll have a short intro to the Tech Academy. We're the ones putting on the free class. We'll let you know who we are. We'll write code. You're going to get your hands dirty writing code. It's fun. Then we'll have a brief Q&A session, although I do try to pick up questions as we move through the coding. We'll go over some information about the Tech Academy and the boot camps we offer. And there's a free gift at the end. Please stick around until the end, and we will be able to get that to you. The whole class takes about an hour and a half. All right, so who are we? Who's the Tech Academy? Well, we deliver boot camps. At this point, a lot of people have heard of them, but up until about 10 years ago, they didn't even exist. These boot camps are really intensive training programs, technology training programs, and they're designed to get people ready for entry-level positions in the technology industry. Depending upon where you go to get a boot camp, they typically last between 3 and 6 months. Some are much longer, but typically it's about 3 to 6 months. And they focus on practical skills using modern, technologies, just to make you attractive to the market, to be able to get a job. Our certifications that we offer, our boot camps, they're cost effective and they're self-paced online coding boot camps. They're tailored for beginners, people with no prior technical or coding knowledge, which is awesome. They thoroughly cover in-demand skills for the tech industry. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule so we can prepare you for your technology career with a well-rounded toolkit. Now, in the US, at least, the average cost of boot camps is $13,500 roughly right now. Ours are under the national average. In fact, we have boot camps that start as low as $5,300. I do want to read our mission statement. It's why we're here. It's actually why we're here tonight, but it's why we exist as a company. Our mission statement is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's why we're here. And our product is you working in tech. I do want to bring up a brand new service, less than a month old, the Tech Academy launched. It's called the Tech Academy Accelerator. I love doing this. This is a monthly subscription program, and it includes live weekly workshops with me. More on that in a second. But it also includes access to over 100 educational videos and over 100 self-paced online mini classes that we've developed over the years. Now, those workshops, where these are introductory classes, the class you're in right now is an intro to coding, right? In the workshop, the Accelerator workshop, we do a deep dive into complex technical subjects. It's meant to be a career accelerator. If you're breaking into tech, it'll help you get there faster. And if you're already in tech, it'll help you advance faster. All these workshops have Q&A included. We have open chat and voice. There's a whole conversation going on while we do the workshop. And we teach topics that are suggested by the Accelerator community. It's a whole group of people in the Accelerator, and we ask them regularly, what do you want to learn about? Because I can teach on anything. Some of it I already know, but if I don't, it's an awesome opportunity for me to learn it well and then teach it to you. So that's the Tech Academy Accelerator. It's only $9.99 a month, and it's pretty cool. Regina, can you drop a link into chat for people that are interested in that? One thing to stress is that, like I said, it's $9.99 a month, but you also get a week free to try it, just to see if you like it, right? So there's a link there. If you're interested in going to fill out the form, it'll ask you to, confirm your email and such. It'll ask you to enter card data, but you're not going to get charged right now. Because again, there's a 7-day trial. So you can cancel anytime during the 7 days. We just want you to see whether or not it works for you. So that's our Accelerator. Yeah, and by the way, we have a lot of fun on these. In the last workshop we worked at, what do you do if you are like working on some cool new technology and you're able to get it running on your machine, right? But you'd like to put it out on the web for anybody to see, your friends, associates, any potential employers, right? And so we're working through taking a full application and getting it deployed out on the web. And it's fun to work through because the real world in terms of technology is fits and starts and mistakes and successes. And we're working through all that in these workshops so you can see what it really looks like to be a technologist, to be an engineer. All right, now we're going to be teaching a free coding class in Python. So let's cover a few fundamental terms before we jump in. First is just a program. A program is just simply written instructions that you can enter into a computer that make it do things. Instead of using a program, which is, the computer's doing some things and you have to react, instead you're on the other side of it. You're putting instructions in the computer to make the computer do things. And then you'll give that program to someone else and they can use the program. You're in the driver's seat. We write these instructions in what are called programming languages. These are just like organized systems of words and symbols and phrases that allow you to communicate with the computer. More precisely, they allow you to create that program, to give the computer specific exact instructions on what to do in order so that valuable functionality is delivered to people. So those are programming languages. And then finally, coding. Well, it's a verb. This is the action of entering those instructions in. If you're coding, it's writing in the instructions. And you will then take those instructions, turn them into a real program that your computer can operate, and hopefully have a lot of fun and get paid well for it. Finally, we do need to cover what's Python. Well, there are thousands of computer programming languages. Python is one of the most popular in the world for a lot of reasons. It was created a while ago, like 35 years ago, by this Dutch programmer, Guido van Rossum. Great guy. My co-founder, Jack, got to interview him about a decade ago, and just fantastic experience. What's really cool about Python is, one, when you read the actual language, it reads very much like English, right? It's precisely formatted, and you have to do it the right way. But when you're reading through a program, it's usually pretty easy once you're oriented to the basics to understand what the program's doing. Python's really awesome that way. And the other thing that's cool about it is very versatile. You can build all sorts of programs, mobile apps, desktop applications, websites, games, all with Python. It's very powerful. All right. So it would be a disservice to you if I just jumped right into coding without teaching you something that is the undercut to this. It's what comes before. And that is, okay, so you're going to create a program. What is a program made up of? And in its most simple and most important form, a program is only made up of 5 different elements, and that's all. And when you know these elements, then learning to program is a lot easier. And frankly, learning additional programming languages is easier. So that's where we're going to start. So these 5 elements, and these are not in any particular order. When you build a program, some of these will come at the beginning, some will come at the end, but others, you just use them when you need them. But here's the first one. It's an entrance point. This means your program has to have a first instruction. If you're going to tell your computer, hey, start that program X, whatever it is, Microsoft Word or a game or whatever you're playing. If you're going to tell your computer, start that program, you need to indicate to the computer, what's the first instruction to run? There's a bunch of instructions in your program. Where do you start? This is valuable for a lot of reasons. When you go through our boot camps, you learn all the different ways this can be valuable and how to leverage this, right? But for simplicity's sake, I'll just say this. When you're given a large program, as an engineer, and you're asked to come on to the team and help contribute to that program, it can be honestly a bit overwhelming at first. It could represent thousands of man hours of work ahead of the time you got there, and it's a big program. And you just want to be able to get in and find out fundamentally, what does this program do? What are the functions in it? And in what order does it do things? Well, the closer you can get in that program to the very beginning, the better and easier it's going to be for you to follow along what the computer does with what the program does, right? So that's why this entrance point is actually pretty valuable in a very practical way. It's not just for the computer to know where to start running the program, but for you as an engineer. So that's the first element. The second element is variables. And like it says, these are pieces of data that your program is going to use, and it's data that can change while the computer program is running. And this is pretty important. If you made a computer program that was going to work with data, and yet that data was fixed, it couldn't change, your program has very limited workability or usefulness to people. And part of the background on this is something we don't have a slide on, but it's actually really important, which is, what's the purpose of a computer in the first place? Why do we even make these super complex electronic machines that cost hundreds or thousands or hundreds of thousands of dollars, right? Well, we did it for one specific purpose. The purpose of a computer is to take in data, to process or work with that data in some way, and then to send that data on somewhere else. That's actually all a computer is for, to take in data, process the data, and then send the data on. There's a lot we could say about that, but knowing that at your core as an engineer is actually really valuable. So if you're going to work with data, your program better be able to keep track of data and acknowledge the fact that that data is going to change while your computer program is running. And that's what variables are for. Then there are control and branching elements. These are decision points in your program. A lot of the time when we're making programs, we're building them to replicate a very human process. Like you're building a program in a business, and there's a process for how to do the day-to-day work of the business. It's probably lots of processes that people have been doing with pen and paper and human interaction, maybe for years. And a lot of their work involves making decisions. Do we ship this order today or tomorrow? Well, the order came in after 3 o'clock, so we're not going to ship it until tomorrow. There's a decision. I'm sure you can think of lots of ways individual workers at a company would have to make decisions, right? We need a way to replicate that in a computer program. So one of the basic elements of any program is, how do we control the flow of that program, which direction it's going to take? And those different directions, those different sets of instructions that could happen, those are called branches. Like they're branching off a main trunk of a tree, right? So you need control and branching statements, or your computer program is not very valuable. One of the next ones, there's only 2 more, and this one's phenomenal. It's called subprograms, and it is what it says. Think of it as programs within programs. Now, that's not all like Inception stuff. There's some real value here. And I'm not going to go real deep on how and why these got developed, but I'll just say this. Very often, when you're writing a computer program, you'll find, as the person making that program, that there's a certain set of instructions that you keep repeating over and over again. There's some rather routine action that every time you need that to happen, you find yourself writing down the same 5 or 10 lines of instructions, lines of code. Well, at a certain point, 1, that's a waste of your time. 2, it's very error prone. What if you don't get it exactly right? And 3, this is the big one. What if you change the way you want to do that certain set of steps, but you've already used it 300 or 400 times in your program? You've got to go back and find every single place you used it and change it to your new, way of doing business. That is a tremendous waste of time. So instead, what they do is they take that set of instructions that you find yourself repeating all the time and package it up in a thing called a subprogram. You give that subprogram a name so you can ask it to run later on. And you set it off to the side. And then when your regular program is running and you need that set of instructions, all you do is call on the subprogram by name. Hey, subprogram A, can you do your job now? And subprogram A runs through those instructions. And then when it's done, it comes back to where you left off. Simple concept, super powerful. So that's subprograms. And by the way, depending upon the programming language, they might not necessarily be called subprograms. They might be called subroutines or methods or functions. It's all the same basic concept. All right, the last element of a computer program. And again, these are not in any particular order. You're going to see as we build out a computer program today that you can put these, most of these, you can put them in any order you want, just based on what you're trying to get done. But the last element is an exit point. This is your end of the program. Why is this important? Why do we care? Well, for this very specific reason. Your computer program is running on a computer. And while the computer program that you wrote is running, the underlying computer is doing a lot of work to help your computer be able to do its job. There's a lot of things we could discuss here, but let's just discuss the simplest one. Your computer program needs to keep track of a bunch of data, right? Well, a lot of the time, the place it puts that data is in devices inside your computer called memory devices. The little electronic devices that can actually store data. So there's only a certain amount of those devices, only a certain amount of room on them to store data. So when your computer program is running, the computer that's running the program will reserve a certain amount of that space allocated just for your program. Why? So that no other program that's running at the same time can use that space and mess up your data. That would not be good. I've done that in the early days of writing computer programs. It was pretty easy to do. There weren't a lot of protections on it, and you could forget where you stored something in the memory and write another program that would use that location, and suddenly you've lost your data. It's tremendously frustrating and embarrassing. So our computer operating systems like Windows or Mac OS or Linux, they do this for us. You don't even have to do anything special for it, to make it happen. The computer does it for you. But that means you need a way for your program to tell the computer, hey, I'm done. You don't need to do anything for me anymore. And that way the computer can release some of those resources that it was allocating to your computer program. So look at these 5 things. The truth of the matter is these 5 elements are actually more important than anything I'm going to teach you after this. Because if you truly understand these 5 things, learning any language is easier. Because this is all there is in a program. There ain't nothing else. Yes, programs can get super complex. I talked about that earlier. But at the end of the day, this is all they're made up of, is only these things. So let's start writing programs. Now you need a place to write. We need a code editor. This is a place where you're going to write the almost looks like English instructions. And in the chat is a link that Regina just dropped in there for you to open the code editor we're going to use. This code editor happens to be hosted on the web. I want everybody to click on that link, take a moment, and you should see something like this right-hand side right here. I'll explain what I'm showing you on the screen right now in a moment. But you should see something like this on the right, where on the left here is a window that says like main.py. Main is the name of the file. Py is an extension that means in this file is Python code. So you should see that when you click on the tab. What I need you to do to make life easier on you is I want you to be able to see what I'm typing and your code editor side by side. Now, if you've got 2 monitors, this is easy. Just put your Zoom call on one monitor and your code editor that you just opened up on another monitor, and you should be fine. If you've only got 1 monitor, well, you have to split them half and half. On the left will be the Zoom call, right? And on the right will be the tab, the browser tab you just opened with the code editor. If you have any trouble like getting these things set up side by side, one of the things you might have to deal with is that Zoom sometimes is not very cooperative. It won't resize and let you move it around. And if you want to get over that, you can past that. You can click on the word Zoom meeting here, and a little button that says restore should pop up on a Windows machine, right? And you should be able to click that, and then it'll let you resize the window and position it. For the browser tab, up in the top right of your browser is this little symbol that looks like 2 little windows on top of each other. Clicking that should make it easier for you to resize the browser. So there's some tips. So I'll give you a second to get that set up. And as a reminder, put my video, the Zoom call, put it on the left, and put your code editor on the right. All right, so we're about to get into coding. So the first thing I'm going to do is show you my code editor. Hold on a second. All right, so there's my code editor. Ignore all that code you see in there. Okay, it's from a previous class I was teaching. And I think I can make it large. Okay, good. That should be a lot easier to read. Okay, good. I'm going to erase all that so it isn't confusing everybody. So again, make sure you set up with me on the left and you on the right. The first thing I want to do is I just want to show you the full game that we're going to build, right? So here's a Python text game. This is an adventure game. You'll get all this code at the end of the class. So don't worry about what you're looking at right now. We're going to do a full tour through this code. You'll understand what's going on here. But I just want to show you it work, right? So you can see there's a bunch of code here. Don't worry about understanding all this stuff yet. Okay. But let's go ahead and run it. Here's the run button. Pull this over so it'll be easier for you to read. You find yourself in a mystical forest. A cliff looms to the left. Do I want to follow the path to the right, walk off the cliff, or investigate the glowing cave? I'm feeling brave today. I'm going to investigate the cave. Oh no, a magical lake blocks your path. A whirlpool swirls dangerously. What do I do? Levitation spell? Swim? Wait for a fairy. You know what? I'm feeling foolhardy. I'm going to swim into the whirlpool. Well, that didn't work out. So, yes, it's a very simplistic text-based game, but it is a game, and you can expand it once we're done with the class today if you want to have fun with it. So that's the game. And again, I just want to demo like the framework in which we need to think today. We're not going to build out that whole game. As you can see, there is a lot of code here. And if we were going to go through all this, we could, but it'd be a 2 to 3 hour class. And frankly, the fundamentals of what I'm going to teach you don't take that long and will probably be more valuable to you than going through every single thing here. But you're going to get a copy of the code and you can play it and mess around with it at the end. So what are we going to do? Well, we're going to take those 5 elements of a computer program that I was saying were so important, and we're going to learn how to do those 5 things using Python. So we'll do 2 things at once. We're going to familiarize you with the basic way that Python works, but we're going to do so by, the second thing, reinforcing those 5 fundamental elements of any computer program. So let's start with an entrance point. You need to have some first instruction. We're going to have a really simple first instruction. We're going to print something over on the right-hand side here. Let me go run. It should empty this out. Okay, good. So I'm just going to print something over on the right-hand side. Now, in Python, the command for that is pretty simple. It's print, lowercase p, R-I-N-T. I want you to follow along. And the way a lot of instructions work in Python is that if you're giving an instruction that's going to do something with data, you have to give it the data inside of parentheses. Well, we have data. It's going to be your name. That's the data, right? And we want your name to be printed on the screen. So we need to put that inside of parentheses. So do me a favor. This is really critical. Give an open parentheses and a closed parentheses. And then make your cursor go back one so you're right in between the two. I'll explain why. The way that Python knows where the data that you want it to work with begins and ends are these parentheses. When the computer itself is actually reading through your Python code, it'll read the first word right there, print, and it'll go, okay, I've been programmed to know that the very next thing I should expect after this word print is an open parentheses, some data to use when I print, and then a closed parentheses. And so the computer will actually find that first parentheses, and it'll, before it does anything else, it'll literally move forward one letter at a time, one character at a time, until it finds the closed parentheses right there. Only when it's found it does it know, oh, good, I've found the end of where I'm going to find my data. And I know the beginning. It's everything between these 2 symbols, these 2 parentheses. And so it takes everything inside there and uses it as the data to actually be able to do the print command. All that is to say that what you want to put inside these right now is your name. Now, your name is text. Your name isn't a number unless you're Elon Musk's child, where your name is a number, 3 higher math symbols, and a cantaloupe, or whatever he named his child, right? Your name is letters. So we're going to give data that is letter. It's called alphanumeric data. In Python and almost every programming language, if you're just going to put some alphanumeric or text data in, it has to be in quotes. So we're going to put 2 double quotes. Boom, boom. Make sure that the double quote, just to the left of the enter key, You need the shift to get it. Don't do the single quotes. And then make your cursor go back one so you're right in between the two. You see what I did there? In the same way that the computer, when it's trying to perform this instruction, will look for the open and close parentheses. It's also, if you're giving it text data, going to look for a double quote and then another double quote. And it considers everything between those two symbols to be the actual text data to work with. So now you can write your name. Your name is probably not Eric with a K. I'm looking at the whole list here. We don't have any Eric with a K. Mark, is that you? Is that my friend Mark from the market? I just saw you listed there in the attendees. If it is, give me a 1 in chat. I want to see that. Okay, hot dang. All right, so this is our instruction. We can run it. I'd like you to do so. Just click on the run, and yay, you did your first instruction. That's awesome. Okay, so I want to point out a couple things, and we'll move on. This reads like English. There's no weird, funky command. I want to point out, and this is a little bit nerdy, okay? But someone had to design this language. They had to decide that this exact word, this exact set of 5 individual letters had to represent printing something on the screen. Now, don't make the change that I'm about to make on the screen. Don't do it. Don't change your code editor. Just watch and learn for a second. When Guido van Rossum, the guy that designed this language, when he designed it, he could have just said the instruction PR means print. He's the one that built the language. He can use whatever word or symbol he wants. But that's just so vague. You can't immediately look at it and understand what it's telling the computer to do. So he didn't do that. By the way, I have been coding since I was like 11 years old. And there were languages that were like that, where the instructions were tiny combinations of letters, and you had to like just memorize this junk. It was horrible. So that isn't what we have. We have nice, you can read it like English. Now, you have to format it perfectly. For example, let's see if this breaks it. Don't do this. Well, you can if you want. We'll put it back. I'm going to put a space in here and run it. That does work. Okay, good. Awesome. But what if I go in here and I forgot this? Will it handle it? Look at the error. There's an error in the syntax. Syntax, by the way, is not a common word a lot of the time. It just means the rules surrounding the spelling and grammatical structure of a language. That's what syntax is. Well, programming languages have the same thing. They have a syntax. And we violated the rules. And it even tells you the open parentheses was never closed. This is exactly what I was talking about a few minutes ago. Try that. See if you get the same error. Put it back and run it, and the error should go away. Well, let's see what happens if you take away the final double quote. Let's see. Will that break it? Ooh, unterminated. Terminated means ended. We began it. We began putting text, or they call text strings, right? We began putting a string in, but we didn't end it. We didn't terminate it. So the errors can very often tell you a little bit about what you got wrong. All right, so let's get back to where it was. So big deal. We made our first instruction. Yay. Let's start using things a little more advanced. Let's use some variables. So let's say that our game, we'd like to be able to display the name of the player. Now, we didn't build that in. I'm using an example here. You're building a game. Very often, you have to choose a name for the player. Well, let's do that. Remember, every single time you play the game, it could be a different player. And a player could change their name while they're playing. Well, if you let them, if you write the program to let them do it. But it's very common when you're playing video games, you can change the name of your character, right? So we should make that piece of data a variable because it's something that could change while the computer program is running. So we're going to make a variable. It's going to be called player. Go ahead and hit enter a couple times. You don't have to hit it twice. We could write our instruction right here under print, but it makes it a little bit easier to read. Doesn't change how the program operates at all. So we want to make a variable. Again, it's called player. Well, the way you make a variable, the name for the data you're trying to keep track of, is just to type the name that you want. Player. Type that out and then hit a space. You've now created a variable. It's that simple. But there's more to it. In essence, what you've done here is you're telling the computer, hey, find a specific location in one of the memory devices in the computer and just reserve it, please. Make sure nobody else can mess with that location in the memory device. And I want you to do one better. I want you to give that location a name. We're going to call it player. That's all you've done, though. You haven't put any data into that location in the memory device. You've just named the location. The thing we've done now, making the variable, is called declaring the variable. I almost think of Michael Scott. I declare bankruptcy, right? You're declaring the variable. But now we need to put data in it. And that process is called assigning a value to the variable. What's the value of the data? Well, you do that in Python by putting an equals symbol, and then whatever's to the right of the equals symbol is the value that gets stored in the variable. So we want this to be, let's say it's Dave. Everybody write Dave. Our player is named Dave. Good, we have a player. Awesome. Well, let's print that to the screen. I'm going to let you guys do this one. See if you can get that information, Dave, to print to the screen. Take a crack at it. And if you get it working, give me a 1 in chat. Good job, Tom. Tom, do me a favor, drop the code that you wrote, just that one line. Hey, Ankar, Paramita, SMRT, good job. Oh, I just got it. I'm sorry, I have to pause for a moment. We have someone in the class whose name is SMRT. So we're just going to pause for a second. I'm going to share a personal story, and I want you to tell me, user named SMRT, if this is actually where it came from. I remember driving down to visit my parents with the kids in the back seat. This is 10, 15 years ago. And all of a sudden I noticed they're singing some really silly song in the back seat. They're just singing over and over again. I am smart, SMRT, I am smart, over and over and over again. Is your username SMRT a reference to that? I have to know. If not, I just told them that would be cool, but no. Oh, darn. Yeah, I love my kids. All right, so there's most of you got this right? I'm actually just going to copy the code out of, I'll just grab one at random, Paramita. And if you didn't get it right, this is how it works. You do a print, and then you put the name of the variable as the information that you're passing into the print command. That's the terminology we would use. Print is a command or an instruction, and we need to pass data into it so it can do its job. And we're passing in the variable. Now, what's super important to see, and you can see it when we run it, is that it doesn't print the word player. Why? Because this is a really critical thing. I like everybody to just slow down and pay attention to this. It's actually pretty important. The type of data that you're working with is one of the most important things to think about when you're writing programs. When we did print the first time, the type of data that we were working with was text data. Again, we can call it a string or alphanumeric data. They all mean the same thing. It's a collection of individual characters, all taken as a whole. It could be a single character. It could be 20 words. It could be a super long paragraph. It's all just text data. But the type of data we're working with is text data. The type of data that we're working with the second time we use the print instruction is not text data. The type of data we're working with is a variable. That itself is a type of data. It's a specialized thing that your computer program is keeping track of at all times. So what specifically occurs when we use this print instruction and pass in a variable is the print instruction goes, oh, you didn't give me text. Okay, that's fine. You give me a variable. I can work with that. What I've been told to do, if you give me a variable, is I go to that location, that named location in memory, in the memory device. In this case, it's the location we call player. I go to that location, and I look inside it, and I get the data stored there. That's what I do. So I don't print the name of the variable. I print the value stored inside that variable. And I know that seems pretty simple, but that distinction just opens up how important it is to think with what is the actual type of data that I'm working with in every single instruction I enter. Again, to reinforce, here we're working with text or string data. The fancy name is alphanumeric data. And here we're working with a variable is the data type. Good, fine. Now, let's say that Dave is having a really weird day. He had 4 cups of coffee and he wants to change his name. I want you to change the player's name, type player, and give it a different name. And he decides his name is Princess Donut, but probably spelled donut correctly. And then print it again, like that. All I'm really trying to illustrate here is that variables are the way that you can keep track of data that can change as the computer program runs. Also, Princess Donut is the name of a character in an incredible book series called Dungeon Crawler Carl. If you start reading those, I want to apologize in advance because you're going to lose about 50 hours of your time over the next week or two, which is really good. Good. So there's variables. I hope you're starting to see how they can be valuable. Okay. Awesome. All right, good. Now, the next thing is these control and branching statements. I want to step back before we write anything and just talk about what we're going to write and why we even care. What we're writing right now, we could consider, like all these instructions you see on the screen, we could consider them the main program. There's a fancy name for it, which is the path of execution. We are executing each instruction one after the other. And so this is a path. You start at the beginning of the path, and you move forward one step at a time until you reach the end. It's the path of execution. But we said earlier that programs should be able to accommodate making decisions. Okay, how do we do that? We do that with instructions that are control instructions. They set your program up for, hey, you're going to be told to make a decision, Mr. Program. I'm going to give you the data with which you can make the decision. So here's this scenario. Remember, we're talking about building a text-based adventure game, and it's pretty simple. One of the things they're going to do all the time is they're going to choose between 1 or 2 or 3 or more available choices. You list out the choices and ask them to choose one. So they make a choice. Now, that also means we need a variable that each time they make a choice can store which choice they chose. So let's start by making a variable. We're setting up our situation here. Give me another enter to give yourself a little bit of space, just again for readability's sake. Let's make a variable called choice. C-H-O-I-C-E. So again, in terms of the terminology, so you start to get used to it, we have declared the variable. I really should use the variable name bankruptcy in one of these classes, just so I can say I declare bankruptcy. I'm sorry, I'm an office nerd. I'm not going to apologize for it. although I just did. So we've made a variable called choice. Let's just pretend that the choices are 1, 2, and 3. That's what we were talking about before, right? When we played the game, you saw choices 1, 2, and 3. So let's just set it to 1. Oh, sorry. I have to assign a value. So give me an equals to assign a value. And then I'm going to give it the number 1. They picked the number 1. Okay, good. Now I haven't done anything with this yet. And this is where it gets really fun. Maybe, depending on your point of view. I said that if we're going to use one of these control instructions, we're setting the computer up to make a decision. And the way you do that is you put in an instruction that's a control instruction, and you give it a condition that it needs to check. The control instruction is something real simple. It's a word we all know. It's if. That's a control instruction. But the thing that needs to immediately follow this instruction is a condition, which is only true or false. Well, it isn't always true or false. It's a condition that can actually be figured out by the computer. We're going to do it really simple here. We're just going to say, well, what if their choice was in fact 1? So same thing as print. We need to pass in this condition. A condition itself is something that the if instruction needs in order to do its job. It needs a condition, a true or false. So give me a open and close parentheses and go back inside the parentheses, and let's give it a condition. What we're checking here is the current value of the variable choice equal to 1? Hopefully you can see how that is either true or false. There's no maybe, there's no ish. That is a condition that a computer can work with. It can, without any ambiguity, figure out whether or not that condition has been met. So the way you would write that one is you'd give the name of the variable, CHOICE. That's the name of the variable. And now we're going to check for equality. Is it equal to the number 1? In Python, the way you check for whether or not something's equal is you put the two things side by side, and you put this symbol in between, 2 equal signs. Not 1, but 2. And that's a totally different symbol than what we used up here when we were assigning a value to a variable. The single equal sign is a symbol that is a totally different meaning to the computer than 2 of them side by side. So I said that on the right, we need to put the thing we're checking. Well, we're checking whether it's equal to 1. Good, love it. Awesome. All right, so that's a condition. We have set up a control statement. The next thing we need to do is we need to write a branch, a set of instructions for what to do if in fact this condition is true. What do we do? Well, let's just make something up. Okay, we're going to make up that if they chose number 1, then they're going to attack a troll. In fact, here, let's have a little fun with this. So let's go back up above choice. I want you to print on the screen, print, make sure it's double quotes, put the double quote, all that, double parentheses, double quotes, right? You face a troll. That's it. I'm not going to list out all of the possibilities. Okay? It'll take a long time. I just want you to get the idea. So you face a troll. Great. And so you list out 3 different possibilities, and they chose 1. Fine. Again, we're not building the whole thing out. We'll see this inside the full code when we're done here. But let's say that, go down to the bottom again. Let's say that choice 1 was to attack the troll. In fact, to make this a little easier, yeah, we will do it. I'm going to have a little fun here because we're doing all right. Go back into you face the troll, go right after the period, and type 1 attack. 2 befriend. 3 trick. Make this wider so you can see. Go ahead and write that in. Yeah, we'll put the choices in. That'll make it even easier to understand. Now, this is a really boring text adventure game. I'm not showing off my writing chops here. Okay. What, you don't like the way I spell print? Good catch, SMRT. Thank you. By the way, I know that nobody else is worried about the mystery, but they shared that that stands for study, maintain, retain, and train. Part of the company ethos. That's actually really cool. I like that better than my silly song. All right, so what do you think is going to happen if you attack the troll? Sorry, dude. I've played, this is going to shock a lot of you. I've played a lot of D&D, a lot of Dungeons and Dragons. That troll is going to take you out. So we need to define for the computer program that we're building what to do if the condition inside these parentheses actually ends up being true at the moment that instruction is being performed. The way you do that is after the condition, right at the end, right after the parentheses, after the condition, give me a colon, and then don't hit enter yet. I want to explain something. Underneath the instruction that ends in the colon, underneath the if choice equals 3 colon, any instruction you put that is tabbed over by 2 spaces will only be performed if that condition is true. Otherwise, it will not be performed. That's just the way that Guido van Rossum happened to make Python work. This is how you create those branches we're talking about. Remember, the instruction we put next may not be performed. They might not pick the number 1. So we're going to structure our program such that the instructions only occur when the condition we care about actually ended up happening. So hit enter. And you'll notice that our code editor, actually very nice of it, assumes that you're going to do that, assumes you're going to create an instruction related to that line that ends in a colon, related to the if instruction. And so it automatically goes over 2 spaces for you. So what do we want to do? Well, we're going to make it simple. We're just going to print, print, and then we're going to print, you chose to attack the troll, he defeats you. You chose to attack the troll, period, he defeats you. Period. Although, if we're going to be accurate, probably he eats you, but that's a little bit gnarly. Okay, good. So we have successfully created a branch. Now, we didn't account for what happens with the other options, but we'll build those in a moment. Let's just sort of test what we've written so far. Right now, let's run this. You see the first instructions, the earlier instructions, they all execute. Then we see the nice print of you face a troll, 1 attack, 2 befriend, 3 trick. Then, because at the moment that we executed this instruction, the value of the variable choice happened to equal 1, then and only then do we actually do this. That's as simple as it is. There's a lot more, complex ways you can set up control instructions and the various branches of code to follow, but that's the essential concept. It's all about conditions that can be evaluated in an unambiguous way by the computer. You cannot ask a computer to guess or be close. It has to be precise. It's just a physical machine. It doesn't think. Recent media reports to the contrary. Computers can't think. Thank you very much. All right, so let's account for the other options. Let's hit enter. Now, this is important. We're done with the instructions that we want to have happen if that condition is true, if the choice equals 1 condition is true. So we need to not be tabbed over by 2 spaces. So we need to hit backspace so that we're back where we started. Don't forget that, or your code will get kind of weird. All right, so let's set what happens if choice is equal to B. I think you do this yourself. If, sorry, not B, 2. Like that. Make sure you got a colon. And now, well, you chose to befriend him. That's great. Okay. Print. You chose to befriend the troll. All right. Drop it in chat. What do you think is going to happen if you try to befriend a troll? Drop in chat your guesses on what's going to happen. I like that. Tom says he eats you. he cooks you dinner. Nathan, that was great. Me cook bone in shoe leather broth. You like? No, they're not trustworthy. He betrays you. See if I can learn how to spell. Sorry, it's a troll. They're not friendly or nice. All right, so does anybody think that that sentence is going to print when we run this code right now? Let's run it. Nope. Now, on your own, before I do it, I want you to make the program print. You chose to befriend the troll. He betrays you. What change do you need to make for that to occur? Reem says we need to assign a value. I like that you use the right terminology, man. We need to assign a value to choice equal 2. That's exactly it. Let's change this to 2 and let's run it. Perfect terminology, man. You chose to befriend the troll. He betrays you. Sorry. That's the way it is. All right. Now, we're not going to finish it all out just in the interest of time. Obviously, if we have 3 different choices, the trick one, we could do that. Actually, let's make it fast. Watch this. Copy just these 2 lines. Highlight them. Copy them. Then go to the end and print enter. Don't forget to go backspace so that you're back where you began. And then paste. And now let's do a equals 3. It's all right to copy and paste on this. So you chose to trick the troll. They're not smart. Now, they may be mean-tempered and physically overpowering, but they're not smart. So what happens is you escape him. Whew, man. So now we have all 3. Let's test it. Let's make choice equal to 3 and run it. Okay, good. Awesome. All right. So now let's get to the final, like, sort of big concept I want to discuss here. You're going to need to check what a person input over and over and over again. So why not turn the set of instructions you do when someone makes a guess into a subprogram? We can even be a little more nerdy and precise, because some of you may be thinking, well, Erik, we're not going to repeat this exact set of instructions over and over again, are we? We could be. Think about this. Let's say the first time you encounter the troll, You're like, oh, I'm a tricksy little person. I choose to trick him, and you escape. But then you're wandering around in the text game, and you encounter him again, and you're given the same choices. I don't want to have to type them out again. Thank you very much. So I want to make a little subprogram just to handle what do we do when we encounter the troll. I'm going to make a subprogram just for that. So let's make a subprogram. Now, in Python, we call them functions, but it's the same concept. And the way you make a function in Python is first you use the word define, or it's actually DEF. DEF. This tells Python, I'm about to make a subprogram or a function. And Python's immediate reaction is, okay, good. Give me the name of it. Let's call it troll encounter. I'm capitalizing it just because I like the way that reads. You don't need to capitalize it. But regardless of which way you type it out, every time you use it later in the program, you better spell it the same way. So I've said I'm making a function. I've given a name for it. And the next thing you need to specify is, does this particular function or subprogram, does it need any information in order to do its job? Sometimes it does, sometimes it doesn't. It just depends on the context of what you're building in your program. But either way, what Python needs to see immediately after the name is at least an open and close parentheses. Now, there could be data inside there. But no matter what, even if you're building this thing where it doesn't even need to take in data, you got to have the parentheses. Good. Now, what do we want to put inside there? Well, what we're going to do here is we're going to take in the current choice that the player made. So we can just pass in or give, it's called pass in, the variable choice. This means, we're not done writing the function yet, but this just means whenever we do ask for this function called troll encounter to be performed, we have to provide it with some information. That information will be the choice that was just made by the player. Good. Now go to the very end, after the last parentheses, and give me a colon and hit enter. Now you'll notice this editor, again, it's friendly. It's been programmed to make you advance over by 2 spaces. Why? Because this is very similar to using the control statement, the if. When you're making a function, once you've given the name of the function and you got that colon, any instructions underneath it that are moved over by 2 spaces are the things that are only performed when that function runs. Otherwise, they don't occur. So what do we want to have happen? Well, we know what we want to have happen. We already wrote it. It's these 3 things right here. If the information that the function received had a value of 1, then we're going to print this. If the information that the function troll encounter received is, the value is 2, then we do this, and so on. So you can make your life a little bit easier by just copying all 3 of these. And then pasting. Oh, I hit Control C again. I think I need more coffee. So copy it, go down, and hit Control V. Now, notice that the copying experience was less than optimum. Why? Because it only indented the first line. Every other line here isn't where we need it. So go slow. Everybody who's following along, pay attention. I'm highlighting all those lines that my code editor didn't handle very well. It should have moved them all over a little farther, and it didn't. So I highlight them, and then I hit the tab key, and it moves them all over for me. And now you can see that we have the colon here, and then we have 3 instructions: this if, that if, and that if. These are the 3 things that will be run based on what information was handed in or passed in to the function. That's how this works. So go to the very end, hit enter a couple of times, but then go back to the beginning there. And we have something really cool. I want to describe the situation we're in right now in our computer program. We have on these lines right here, in creating this function called troll encounter, we've created a little reusable package of code, a little reusable set of instructions that will only be run when we tell them to somewhere in our code. And that's an important thing. Right now, this function will not run, not because we made any mistakes in writing it, but because we haven't got an explicit instruction anywhere in our program that says, hey, you know that function called troll encounter? Can you please do that now? You have to do that. So let's show how that would work. Let's go all the way down to the bottom like we did. I'm going to hit enter a few times just to be able to make it easy for you all to see. So let's say we're bebopping along and you're the player, and the first time you encounter this troll, like I said, you're getting pretty tricky. You're like, I'm going to trick this guy. So let's say the first time, type your variable choice. The player chose, make it equal to 3. All right, good. All right. So now, instead of writing out all these instructions right here, these 3 control statements, followed by the branch to do, like instead of doing all that, let's just ask for this function to run. So on the very next line, after making choice equal to 3, call that function. Ask for it to be done. And the way you do that is just type the name of the function. Now, this is where the capital choices and lowercase choices you made are super important. You've got to spell the name of the function the exact way you did before. In fact, there's nothing wrong with copying the name of the function and going down here and pasting it in. There's nothing wrong with that. It's smart programming practice. Make sure you avoid a silly mistake. That wouldn't be a mistake that I've made 10,000 times, but some people make that mistake. So you type the name of it, and then you need to give it information. So give me some open and close parentheses. Give it information. Give it that variable choice. And now it'll run. So the last message, we've got a bunch of messages going on here, but the last message you should see is you chose to trick the troll. So run it. And this is where we actually used that function properly. You chose to trick the troll. You escaped him. Okay, good. All right, now, let's say it's a little while later. You've been playing around in different parts of the game, and all of a sudden you took the wrong corner, and you're staring at the troll again. And you're like, go and hit enter. Make a different choice. CHOICE space equals. This time you're like, man, I'm sick and tired of you coming along the path every time I'm trying to get out of here. I'm going to attack you. So make the choice be 1. And now call troll encounter again. And give it the new value of choice. We're on that bad boy. Oh, sorry. You toast. So I hope you can see just in these 4 lines of code right here, how much easier it is to think with your program, to manage your program. For example, let's say the designers of the game are like, you know what? We're trying to make this a little more like visceral and like want to feel like the fight and the blood. So when you choose to attack, we're going to change it to he beheads you. Oh, that's brutal. Well, you probably spell beheads right. So run it again, guys. Look, he beheads you. Why do we care about that? Why is that important? It's actually huge. We only needed to make a change in one place inside the function we've made called troll encounter, and every other location in our program that makes use of that function, that change gets used there. It's so much easier to manage a large computer program when you organize it this way. Now that's fun. Let me show you the next step. Let's look at the real game. So, Regina, can you put a link to this code inside chat? Once you get the link, go very slowly. I want to show you exactly what to do. All right, so there's that link. Grab that Google Doc link, copy all of the code in it. Best thing to do is click somewhere in it and do Control A and Control C. Sometimes people drag their cursor and they miss part of the program and it messes everything up. Grab it all and then go over here to your code editor, click anywhere in your code letter and do a Control All, delete everything. And now paste in that new code. Now, I want you all to take 1 minute and just play the game. Hit run and just play the game, folks. I'm going to grab a sip of water, and then I'm going to show you what's inside the code for this game and how you'll probably understand it a little better now. All right, what am I going to do? I'm definitely not going to walk off. I'm going to follow the path to the right. Let me try that. Wise choice. Magical way. Yeah, I'm being a little more conservative. I'm going to wait for a fairy. Okay, good. Oh, a wild bear. Oh, calm down there, big old bear. Ooh, it worked. Hidden robe, mystical. Oh, I think it's really bright to help other people. I'm going to plant a seed. Oh, Bryson. Dance? I'm not going to join their dance. That's dangerous. Nope. Sorry. I'm going to politely decline. Later. Okay, so there's the game. Let me show you a couple things. If you're playing, go ahead and stop for a second. I want to show you something kind of cool. First, let me explain. Go to the top of the program, and you'll see this instruction here called import. We can get really nerdy on this, but the short version is that instruction lets our computer program use someone else's code that was pre-made. The pre-made code happens to be really good at generating random numbers. That's all. But that's all import is bring some other pre-made code into my program. That's what it is. So let's look here. So what you got here is a function called init. And let's go down. Here's a function called shuffle options. Pretty good name. Here's a function called play step. By the way, the green is just comments. The computer doesn't do anything with those. They're just there for you and for other people to understand your code. So we've got a function called play step. If we go down here, it's a function called end game. Okay, good. There's a function called start game. Good, all right. Huh. So all we have so far is a bunch of functions. Remember I said, yeah, I'll get that question in a second, SMRT. Remember I said that functions don't do anything unless you actually call on them. So notice we're at the top of this and we're going down. How many lines of code? We're all the way down here. We are like 140 some odd lines of code. and there's not a single instruction that is actually being asked to be performed. We're just creating a bunch of functions. So where does the real work begin? And remember, I said that there's 5 fundamental elements of any computer program, and that one of them is the starting point. We haven't even reached the starting point yet. Without knowing that, you might start to spend a bunch of time reading through all this code at the top of the file. And you can do it, but it's harder because it doesn't follow the way the computer program is going to actually run. The first instruction. This is, by the way, this is a weird way that Python sets up the first instruction. Don't worry about the syntax here. You'll learn all that on a boot camp or studying Python, okay? But this is actually the first instruction. Run this function called start game. That's the first instruction. It's at the bottom. Now, is that weird? Yeah. But it's the way this language works. And so, remember I said earlier, if you learn these 5 fundamental elements of any computer program, it'll help you learn any language. And the approach is just figure out, how does this language do those 5 things? So you can even Google, how do you find the first instruction in a Python program? And you'll get information about the fact that, oh, well, usually there's this weird syntax with name equals main, and in there, you'll find the first instruction. Huh, thank you. So we found it. It's called start game. So we can go here, start game. Oh, okay, and you can start to look up some of these words. Well, it looks like while the game isn't over, run play step. I saw that earlier. That's one of those functions. And you go up, you go end game, play step. Oh, so as long as the game isn't over, keep running this function. What qualified as the first function is simply that it's what we listed right here. We made it the first function. That's all. That was a question that Reem had. It was good. So again, we're not going to follow through all of it, but I just wanted to show you, first of all, knowing that there's a first instruction matters. Then variables. Well, you can see variables all the way through this bad boy. Let's go up here, and we have points as a variable. We're assigning it a value. Look, choice is a variable. Okay, now, this is more complex than what we did, but look at this. Isn't this really just, give me a 1, 2, or a 3, please? It's the same concept. It's a variable. And then, oh, if they didn't choose a 1, 2, or a 3, then that's an error. Okay, good. So again, I know there's a lot going on in this program, but I wanted to point out that even armed with what we've covered tonight, you can start to at least piece through this and understand some of the fundamental things it was doing. And at that point, you're just Googling and looking up a few words, and you could start to understand most of how this program works. For a full understanding, you'd want to do formal study, which is where boot camps come in. But I hope you can see that it really is just, what are these 5 elements, and how does this language implement them? All right, I want an opportunity for people to have Q&A. So, and I've seen some in here, so I'm going to pick up some of them, okay? Let me go back here, and we'll do our Q&A. Let me see what we got here. We've got probably time for one question here. Oh, SMRT has a really good question. It said, random question. Is it possible to, quote unquote, inspect the import function to see the underlying code? That was actually a really good question. And the fact is, yes. When you bring in, they call them a library. When someone else made a bunch of pre-made code, you can call that a library. You can absolutely go look at that library when you bring it in. You can open it up with a code editor, and you can read through, and you can start to make sense of it yourself. That was a great question. And by the way, a responsible programmer will do so, because otherwise you're trusting someone else, and you never know whether they put something in there that's harmful to your program. They put in some virus, they call it malware. That's happened. It's happened more often than you might think. All right, good. Okay, that was a good question. I appreciate that. All right, so we're looking at we got about 10 minutes. So let's talk about the school. Who are we? Why are we here? Well, first of all, please stick around for your free gift. It's coming your way. I think you'll like it, right? We offer boot camps. We offer 12 coding boot camps. and they cover a wide range of subjects. You can see here things like artificial intelligence. Thanks, Nathan. Computer programming, website development, cybersecurity, design, data science, video game development, which is cool, mobile app development. In fact, we have more certification programs than any other coding bootcamp on earth. Our boot camps are self-paced, but also instructor-supported. They're flexible. Students set their own schedule, and they can enroll 365 days a year. You can enroll anytime. The boot camps are affordable. They're priced under the national average. And all of the boot camps include both job placement training and job placement assistance. We want you to get hired. Most importantly, the programs are designed for absolute beginners. There's no technology knowledge or experience required, so you don't have to be a nerd. You might want to get a lot of the stupid jokes that I put in the curriculum, but you don't have to be a nerd. And who are our programs for? Anyone looking for a better career. I was thinking about this today, actually. The idea of a living wage has almost become a joke, at least in this country. There's so many roles available to people, so many jobs, that they don't actually pay a genuine living wage. And that isn't true in tech, which is pretty cool. So it's also good work-life balance in tech. There's remote work opportunities available. So this is what we help people do. And we do it well. We consistently land on every single major best coding bootcamp list that's kept about the industry. We also get great reviews. Our average review rating across all major bootcamp review sites is 4.8 out of 5 stars. And that's based on student and graduate feedback. These are people that know whether or not we deliver what we say we're going to deliver because they've been there. And this is what they have to say about us. So a couple of questions. Why consider working in tech? I mean, if you got on this call, there's probably some, or this meeting, there's probably some interest in technology. And you probably got some answers already to these 3 questions. But I just want to point out a couple of things. One is that technology, you do have good work-life balance in general. There's rarely jobs where you're working, horrific hours or have awful bosses or whatever. And increasingly, especially with COVID, remote work is possible, which is great, right? It's also a very creative industry. It's dynamic. You work with other people to build really cool things, and you can take a lot of personal pride in your work. And finally, it's a very stable industry. For decades, there's always been a shortage of technology workers. It doesn't mean it's super easy to get that first job. You still have to work at it, but there's always more jobs than there are engineering talent. Always. It's been true since, I started keeping track in about 1987. And it's been true every year since then. And if you work really hard, you get regular increases in pay, which is cool. Now, that said, there are barriers to going the route that we provide. We provide boot camps. There's lots of areas to go into school or self-study, but I can talk to you intelligently about boot camps. Boot camp tuition costs thousands of dollars. We provide multiple financing options, including a big upfront discount. You can just come up with the tuition all on your own, right? Also, we have monthly payment options for people with no credit or bad credit. In fact, there's a tuition option for anyone, no matter what your financial condition. The fact is, though, getting a Tech Academy bootcamp done is an investment in yourself. You're arming yourself with the fundamentals of some of the most valuable skills in the world and getting current practical tools that employers want. But it does cost money, and we help you with those. There's also the barrier of time. It takes a little while to learn this stuff, folks. So some boot camps approach that time problem in kind of an interesting way. They require all the students to go through the training in one cohort. They'll have set start dates. You can sign up, but you don't begin yet. And then everyone starts on the same day. And they all move through the curriculum, first of all, pretty much full time. And second of all, they all move at the same pace. And in fact, some boot camps require that you be there in person in order to help just make sure they can do whatever they can to get the data across from you. What we've accomplished is actually pretty cool. All of our programs are online. You can choose your study schedule. And you can study part-time if you need to, which means you can study concurrently to going to school or having a job, which is pretty cool. Finally, in order to get through a boot camp, you need to have some technical interest or ability, which if you're on this call, you probably have some, which is awesome. I will say that if you felt like overwhelmed or confused by any sort of attempts to break into tech, some of the technology education materials that are out there are honestly too hard. And they're too hard, not because of you, but because some educators assume too much prior knowledge on the part of the student. I made that mistake early on when we were forming the curriculum. And thankfully, I've got a really good co-founder, and he pointed it out. Our programs, you don't have to be a nerd to get through them. You don't have to have any technical background to enroll, and you can get through. So if any of this makes sense to you, I have a question. Are you working a dead-end job with an income ceiling, or you look at the career trajectory and you're like, man, this caps out at a place I want to earn more? Or maybe your work-life balance isn't good. Maybe you don't have a job right now, or you want more time with your loved ones. The whole point is it time for a career change? If it is, the Tech Academy is the answer. We are career change experts. This bridge on our logo is there for a reason. We're trying to be the route into technology for everyone, the bridge across that gap of sometimes confusion and uncertainty and overwhelm. And at this point, we have a decade of experience breaking people into tech. Most of our graduates make on average $30 an hour in their first job, which is $60,000 a year, right? So if you're wanting to switch careers, you can usually do so without taking a pay cut, which is kind of cool. And it isn't just a few. We have over 1,000 graduates working in tech, anywhere from small businesses all the way up to the big companies like Epic Games and Uber and Disney and Facebook, Nike, right? So as a reminder, we have open enrollment. So you can start anytime. And I encourage you to enroll. This is how you do it. You go to this link. Regina's just dropped that link into chat. And as a reminder, stick around for your free gift. We're almost there. When you go to that link, you'll be taken to a very simple sign-up form. And after the form is a series of steps that will give you a ton of information about the school. Videos, articles. There's even an optional step to book a call with our admission folks. And so I just encourage you, once the event's over here in a few minutes, complete those steps. Find out more. Yes, make your own decision, but we've attempted to give you as much data as we can. So I'm going to take a moment and take a sip of water because I've been talking a lot. I hope no one on this class tonight was not an Office fan, because I went in hard on the Office references. By the way, if you click on that link and you're taken to a login page instead of a sign-up form, it just means you already have an account with us. And if you're not sure if you're using them or passwords, there's some guidance at the end of this slide, at the bottom of this slide, that will tell you how to log in. Yes, SMRT says, I got to catch up on the Office. I've come to the conclusion that for me personally, like, the catching up is a constant process. I listen to the Office Ladies podcast, which is amazing, by the way. I listen to Jenna Fisher and Angela Kinsey on the Office Ladies podcast every week. It's required listening for me. And that just means I have to catch up on the episode because they're doing every episode in order. So, love it. Tom, I think you're right. He says, by the way, the song your kids were singing is a Simpson reference. Homer sings it. You're right. I am smart, SMRT. Thank you. I was thinking about calling my son up when I got done with the class and saying, you know, when you're in the back seat. Okay, good. All right, so another quick thing I want to mention. Our graduates really, really like us, obviously, right? And because of that, referrals to the school have been one of the top enrollment sources we've had over the years. And so we instituted years ago a commission payment for people that refer others. It's 5% of the tuition. So in a moment, we're going to give you an email address to send in to get your free gift. When you email in, if you include referrals, like include their name and their contact data, if they end up getting, paying for the Tech Academy, we're going to save you 5% of their tuition. No questions asked, and we'll be glad to do so. All right, quick word here. We have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, which is awesome because it explains all these super complex technical terms in simple, clear English. And we have a project management handbook, and finally, a book called You Are Not Stupid, Computers and Technology Simplified. You Are Not Stupid is phenomenal. It's basically a written version of the first and most important course on all of our boot camps, which is called the Computer Basics course. It has all modern technology terms and concepts defined, and it even includes a history of technology that shows how we arrived where we are today. So technology and computers will no longer have any mystery for you when you're done reading this. So the gift, we did a Python class. The free gift is our Python book. This book goes way beyond what we taught in this little 1.5 hour class, right? It covers those 5 fundamental elements of any computer program in even greater detail. You learn Python with more and more examples of building those 5 different things, and you learn a lot more than that in this book. It's really quite good. This, unfortunately, this is a physical book we're going to send to your house, but unfortunately, we can only do it for people in the US. So if you want a copy, grab the email address that Regina just dropped into chat, books@learncodinganywhere.com. If you'll send us your name and your physical, a physical address we can send something to, we'll send you a copy of the book for free. Also, if there were any questions I didn't get to, you can write them in the email. They'll get sent to me. And if you have anybody you want to refer, put their name and contact data in there, and we'll keep track of it. And if they sign up, we'll send you a commission. So I'm going to give people a moment here if they want to fill out that email. And then I'm going to give you all of our links for anything you want to do to connect to anything with the school. All right. So we use a service called Linktree. If you use this URL, Regina's going to drop this into chat. If you use this URL, it'll take you to all of our Tech Academy links in one location to make it easy. Okay. There's links to our free YouTube video playlist with a bunch of free educational videos. There's links to our books and our dictionary, our upcoming meetups, future classes, and of course, all of our social media accounts. So please follow us on social media. Invite your friends to future classes, future meetups, and tag us. In fact, if you want to win your own copy of You Are Not Stupid, all you got to do is share a link to the next class, the next event, share it on social media, and tag us. We're going to find out because you're going to tag us. We keep track of that. And all the people that do that in a given week, we pick one of them out of a hat, and we send them a copy of You Are Not Stupid. All right. Thank you so much for attending. I hope you got something out of this. I hope it was helpful. If it was, please tell your friends and have them come to these. And as a reminder, if you filled out that form to find out more about the boot camps, here's the link again. If you filled out that form, when we're done here, go through those steps, find out more, see if it's a fit.